The Taurus Littrow site for Apollo 17 is one where at the mountain front of the Serenitatis Basin, you'll be hearing the names South Massif and North Massif as we explore that part of the moon. At these fronts, or massif, the sides of the massifs, or mountain complexes, there is an excellent probability that because of the event, the impact event that formed the Serenitatis Basin, that we have exposed several thousand feet of section, or a stratigraphic section, as the geologists refer to it, that is a sequence of rocks which were formed in the very early history of the moon. Now, there are some other alternative interpretations, but the one that is most likely is that we will see rocks that form the early lunar crust. Now, the alternative one, the best alternative, is that we'll just see materials from that early lunar crust that have been thrown out by other impact events and form a layer cake of rock units in that part of the moon. But the probability is also very high that we will see some of the materials that form the original lunar crust. Now, it may turn out that those materials are fragmental rocks or breccias, if you've been listening to these lunar missions before. However, the big emphasis there will be to see these very old rocks that will help push this history book of the moon back into the time before 4 billion years, or hopefully right up to the very earliest possible time that we can examine on the moon that we know about, potentially as old as 4.4 or 5 billion years old. Now, on the other end of the spectrum, we have this very dark cover, our mantle as we call it, over the site, which from all the evidence that we now have, there's evidence using radar from the Earth, there's photographic evidence now with the Apollo 15 pictures that were taken from orbit. All of this evidence indicates that this is fine-grained, fragmental debris again that resembles, in every characteristic that we've seen it so far, the kind of volcanic ash, or very similar kinds of volcanic ash that you find in the western United States, such as Flagstaff, Arizona, for example, if people have been there. And from other lines of evidence, such as the number of impact craters that we see on this covering surface or mantle surface, we can predict that the age of that surface, the age of formation of those materials, is very young relative to other rocks on the moon. It may be as younger than 1 billion years. There's some lines of reasoning that say it's younger than 1 billion years. Now, that still sounds like pretty old rocks. And on Earth it is. A billion-year-old rock is a very old rock. There aren't that many billion-year-old rocks that you run across in your everyday walk down the street. But it is reasonably common on Earth. However, it represents, that billion years represents most of the history of the evolution of life on Earth that we know about. Whereas on the moon, we're saying that's one of the youngest rocks that would be one of the youngest rocks that we found. So it's sometimes difficult to maintain this dual perspective of the Earth being a very dynamic and very young, geologically speaking, environment, whereas the moon has been very static for really literally billions of years. The history is still important. It's static history, but it's extremely important to us, as I hope I have indicated. Now, the continued investigation of the sun by looking at the soils on the moon will be enhanced at the Taurus Littrow site because of the existence of several surfaces that have been exposed to the sun for varying lengths of time. So we can see not only the integrated effect of several billion years of exposure to the sun, or say a billion years of sun, but we can see the stepwise effect. And so the dark mantle deposit, which is one age in one place, is covered by what you'll almost certainly hear people refer to as a slide, a landslide. More literally speaking, if you want to remain objective, you would call it a light mantle deposit, which is what it really looks like. But the probability, again, is high that it is a landslide off of one of these mountain fronts. That is younger yet than the dark mantle surface, as near as we can tell, and therefore represents another horizon or another unit of time that we can examine the effect of the sun on. Plus, we have the very old rocks potentially in the front, and the soil developed on them, and in a couple other very specialized locations, we have the possibility of seeing even other ages of soils. So, obviously, I'm enthusiastic about the total potential of the site to look into the two major questions, that is, understanding the Earth better through the moon and its early history, and understanding the sun better through the exposure of its soils to the sun. And then, of course, there's this other thing of the unexpected, and who knows what that's going to be. And that's really what makes it exciting. I think, just like everybody else who's flown, I and all the people who fly with me and after me will bring very special experience to the program. Experience gathered generally prior to becoming an astronaut, and then added to or augmented while they have been an astronaut. My experience, and it just happens to be in the field of geology, and in particular in the observation of materials of the Earth in their context as they exist in the field. That's what basically a field geologist does. And I've had a number of years of experience doing that, and I've continued to do that since I've been involved in the program. Plus, I've extrapolated that experience into some detailed examination of lunar problems. And so what I really bring as a specialty is the ability, hopefully, if my experience is any clue, of being able to integrate what I see and apply various working hypotheses to it, and which in turn not only tells me what I should sample or what I should say or what I should photograph about what I see, but it will lead me to other observations. And this is something you gain by experience, no matter what field you're in. Field geology, aircraft flying, test piloting, botany, poetry, law, you name it. What you gain by experience is the rapid synthesis of what you're exposed to, and a projection of that exposure into the next step. It's really the scientific method, and you can, if you want to, you can apply it to any field where you become a professional or particularly adept at that particular endeavor. And so I don't feel myself very unusual in the respect of being a scientist, because we've had specialists before, and I'm really a geologist going to the moon, and we've got other types of scientists going on the Skylab program. Physicists, solar physicists, a doctor, a medical doctor, and we're just gradually evolving a phase of the exploration of space where we're now trying to apply specialties to the particular problems we have to deal with. And in the case of exploring the far frontiers of space, or of any geographic environment, if you will, a geologist has an advantage. It's because that's what he does. That's his livelihood, and that's what he's been doing most of his life. And hopefully we open up with this the possibilities of applying other specialists to other problems, and which we are doing. The Skylab program will have a doctor and two physicists on the 3 flights. So I don't feel that unusual. A lot of people think of it as being unusual, but it's really just another specialty.
Apollo 17 is what we call a J mission series, or it's a follow-on to Apollo 15 and 16, where we really sort of changed the capability of the spacecraft, where we added a lunar rover to the lunar module so that we could go further distances from the lunar module after we landed, get into areas in terms of geological exploration and exploration of the moon that we couldn't get to before. We have more payload on this flight. As a result, we have quite an extensive and heavier scientific package in our spacecraft, which of course means it takes longer time to deploy it, to set it up, to get it working. With that in mind, and to spend additional time on exploring the geological finds we hope will be in Taurus Litra, our landing site, we hope to spend a little bit longer time on the lunar surface. With the addition of the rover and more confidence in its ability and capability to navigate and go further distances without problems from the lunar module, we will now go into areas that heretofore would have been considered inaccessible. The basic major objectives are to follow on to the previous flights, especially Apollo 15 and especially Apollo 16, and as we sort of think of it, try and put together those ideas, try and put together the works and the words and the paragraphs of sort of the final chapter for some time to come to be written of all of our lunar exploration. We hope that geologically speaking, we'll be able to uncover rock types and different types of geologic finds that date back from the very beginning of the moon's history, to the present time. And of course, the major objective here scientifically is to be better able to understand our own Earth, our own evolution of life as our Earth knows it, our own environment, and maybe better predict what has happened and what might happen in the future concerning civilization here on Earth. Well, in spite of the fact that I've had a chance to fly a couple times, I haven't, and I've been close to the moon, I haven't made that moon landing, and believe me, it's no easier for me today than it ever was, no matter how many landings we've made before. We're obviously smarter. We know how to do it in ways that are a little bit better than we knew how to do it before. We have eliminated some risk, but when you get more sophisticated, when you get more confidence in your system, and you try and do more and go further, you sort of push your entire system out to what you consider the limit of, if you want to call it risk, or the limit of capability of both you and a spacecraft. So no, I don't think they're any easier today than they were in the past, and certainly they're not for a crew who's never made that lunar landing before. Oh, there's no question, but having flight experience, whether it be well, experience in anything, whether it be driving an automobile or flying an airplane, and certainly something as unique as flying a spacecraft helps you. And I think especially not just flying a command and service module, or not